This is a rock. You can tell because it says rock on it. Sometimes this happens to rocks. This is what we call weathering. Don't forget that red slides are where you have to take notes. You should have your notes handout ready to go. Don't forget to look for the owl and let me know where he is. And remember to fill in all of this stuff that you see here. So I want you to take a guess at what you think caused the rock formations in the following slides that you're about to see. So here's one. We have some mountainy looking things here, and we have some water. You can see some very large sized rocks out here in the water, and you can see some very rounded kind of rocks. So what do you think caused all these rounded rocks here? All right. Well, these rocks were moved around by the waves here, right? And they smash into each other and kind of round them off. Okay, how about this one? So we can see that there's a bunch of cracks here and that these rocks have started to break down into smaller pieces. You can see some of those smaller pieces and they're kind of breaking off here. What is causing that to happen? It looks like the tree roots here, right? So there's another thing that can break down rocks. How about this one here? What could have caused this big gap here in these rocks? Well, you might be guessing wind, maybe, right? This is a picture of Watkins Glen Gorge. I've actually been here before a couple times. Really cool place. And so what's with all of this area here? Why is there this sort of this steep walls here? What caused that to happen? Well, this running water caused that to happen over a period of, I think the sign said there something like 12 or 20 million years or something like that. It takes quite a while for that to happen because after all, this is rock. What about that one? That's kind of interesting. Well, if we look really carefully here, we can see that there is some water back here. This is actually a beach. You can see a couple people there. And so we might think that maybe during high tide, maybe the water comes up to this level and doesn't quite make it any further. And so it's worn away at that part of the rock there. How about this? This is kind of a hard one, huh? This is actually caused by water sitting on this rock and a chemical reaction happening between the water and the rock, which wears it away. And as you start to wear it away, then you get little pits in the rock. And of course, when you get little pits in the rock, the water stays there longer. It forms little pools in those little pits there. And so you get more of that weathering happening, more of that wearing away in those little areas there. What is this a picture of? Yeah, you might have seen this before. This is a footprint of one of the astronauts that landed on the moon during the Apollo missions. So it's still there, most likely. I don't know. I haven't been there personally, but most likely those footprints and all of these little tracks that you see here and everything are still there on the moon. So why is that? Why are those still there? Why haven't they been moved around? Why haven't they been blown away? Well, the reason is because there's nothing on the moon to do that kind of stuff. There is no atmosphere on the moon, and there is no running water on the moon. So these are the types of things that would make things wear away, things like footprints or things that like breaking down rocks into smaller pieces. It's mostly the movement of fluid substances on Earth that make that happen. And by that, I mean the movement of air and the movement of water that breaks things down. And that stuff doesn't happen on the moon because it doesn't exist on the moon. So here is our atmosphere. We've learned a lot about that. And here's what our atmosphere does to things, right? So we have some wind weathering going on there. Here's a nice fast-moving river of water here, and that can do a whole lot of weathering and wearing down rocks, and can even lead to something like this, something that we've already talked about quite a few times here, which is the Grand Canyon. And so if you give it enough time, you can actually create these huge, gigantic land features here where the Colorado River has basically worn away all of this land here and created one of the largest geological features on Earth, the Grand Canyon. We also have oceans. Oceans, the waves of the oceans and the tides of the oceans can break things down. That's why there's sand at the beach. They used to be big rocks. Now they're just little pieces of rocks that we call sediment. You should know that. There's some sediment right there being broken down, and you can see the different sizes. So eventually these big rocks will get worn down into these littler rocks, and these littler rocks will get worn down even smaller rocks. Interestingly, there is some weathering. If you're really thinking about that idea of the moon, you might think, well, why aren't there just big rocks on the moon then? What's with all the dust? How did that get there? How did it get broken down into little pieces? Well, this picture has a bit of a clue for you. This guy right here and these big ones right here, those are impact craters from asteroids, and that's usually pretty much the only thing that does any weathering and erosion on the moon are impacts from asteroids. On the other hand, you have Mars, and Mars is a very interesting case. What we see up at the top here of Mars is one of Mars's polar ice caps, and so Mars has water on it. There's been a fairly recent discovery within the last couple of years or so that Mars actually has running water on it. And so we have known for a long time, though, that Mars used to have running water on it a long time ago. And one of the reasons why we know that is features like this right here and this right here. These are actually the old areas where rivers used to be running on Mars and created these features like this. So that used to happen on Mars, but Mars doesn't have much of an atmosphere anymore, and Mars doesn't have very much running water, at least. So everything we've been talking about here falls under the category of what we call weathering. And weathering is the physical or chemical breakdown of rocks into smaller pieces. There are a few different types of weathering. So let's go over those. There is mechanical weathering, and that means that it is broken down physically. Think like taking a hammer and smashing a rock, okay? Pretty simple. We have a few different kinds here. Ice wedging. This is when water seeps into cracks and freezes, and over time, if that's repeated over and over and over again, you will get features like this where the rock cracks and breaks into pieces because of that. One of the things that you need to know in order to understand this, hopefully this has never happened to you, but it may have, when you put a soda or something like that in the freezer, the thing about water is that it has this kind of unusual thing where when it freezes, it actually expands. Usually things contract, they get smaller when they get colder, but water actually expands when it freezes. And so that's what kind of breaks apart the rock. You get water that goes into the cracks of the rock, and then when it freezes, it gets a little bit bigger and it opens up that crack a little bit more, and then that process repeats over and over again. And in some cases, you can get something as extreme as this. This is what's called the Old Man on the Mountain. This is in New Hampshire, and this is what it used to look like right here, and you can kind of see it looks like the profile of an old man. And this is a completely natural feature. This isn't like Mount Rushmore or something where humans made it. This is something that just naturally occurred and happens to kind of look like a face. But after time, because gets very cold in New Hampshire, all of these little cracks that you see here, water would seep into those cracks and it would slowly push those cracks apart, and eventually that whole entire face fell off the mountain. There was actually a lot of debate in New Hampshire about whether they were going to try to preserve it or not, and they decided not to, which I think is probably a good choice, because after all, it was a natural feature in the first place, so I guess you just let nature take its course. On the other hand, same type of thing happens to Mount Rushmore, but because it's a man-made sculpture, I guess you could call it, they continuously do repair work on that. All right, next one is called abrasion. This is when sediment rubs against rocks. Think of this like sanding wood, okay? This is how we get rocks to look like these pictures that you see here. You can see these little scraped lines here that are an indication of abrasion. The smoothness of the rock is an indication of that. This is, yeah, that's my mom's house right there. That's where she lives, right on Lake Ontario. And this is what the beach of Lake Ontario looks like. And this is a really good example. I have some of these rocks in class that I can show you. And the reason why it looks like this on Lake Ontario is because of these waves constantly going in and out and moving these rocks around, and they kind of bump into each other, and they the sharp edges and corners get worn away. Finally, as far as mechanical weathering, we have biological weathering. And this is generally caused by plants and animals, like the picture of that tree that we saw. It could be worms, it could be moles, there's all sorts of different things. It could be lichen that kind of attaches to rock and breaks it down and things like that. But a lot of times it's tree roots. You've probably seen like cracks in sidewalks and things like that. That's a good example of that. Now, the other side of this is we have chemical weathering. And chemical weathering is weathering that is broken down by chemical reactions with the environment. That word right there is environment. I know it's kind of blocked, but environment. So, a few different kinds. We have oxidation, which is when iron combines with oxygen. This is otherwise known as rust and usually causes kind of a reddish material. This is actually why the surface of Mars is red. It's for the same reason that this soil right here is red. It's because it has a lot of iron in it, and that iron literally rusts when it comes in contact with oxygen. Our next one is called hydrolysis, and if you kind of look at this word, right, hydro, like hydrate, right, that's water. Okay, so this is when you have a chemical reaction between the rock and the water, and you form these kind of pits in here, because as I said before, the water will sit in those little indentations and then wear it away even more. And we finally have what's called acid precipitation. You've heard of acid rain before, probably. This is not acid like it's going to eat through your skin, but it is rain that has combined with things like carbon dioxide, nitrogen dioxide, and sulfur dioxide, and that forms a slightly more acidic water. This is actually something we talked about when we discussed climate change and the idea that the more carbon dioxide that we put into the atmosphere, the more it makes the ocean acidic, which is really bad for the life in the ocean. But it also makes the rain more acidic, which is, I guess, bad for rocks, maybe? This is a statue called Cleopatra's Needle. And Cleopatra's Needle is in New York City. Okay, it's in Central Park, New York City. It's a nice little statue. Now, it didn't originally start in New York City. It actually started in Heliopolis, Egypt, and was made in 1450 BC and was a gift from Egypt to the United States. They actually had three of them. One went to the United States, one went to France, and one went somewhere else. So it was shipped to New York City in 1878. So this is a long time after it was made. And this is a picture from it 2 years after it got hit there in 1880, and you can see that it's pretty well preserved. You can see all the different hieroglyphics on it and stuff like that, all the different shapes pretty well. It's not worn away very much after thousands of years, right? Now, in 2010, not too much longer, you have all of this wearing away going on. So what's going on with that? So the question is, after 130 years or so, this thing has gotten almost completely weathered, but it was able to stay unweathered for thousands of years in Egypt. So why exactly did that happen? Well, the reason is we need to start off with what this statue is made out of. And a lot of what the rock is made out of is red granite. And the thing about red granite, and the thing that makes it red, is it's made out of a lot of feldspar, and you should remember feldspar as being one of the minerals that we studied, and that's the red stuff in red granite. And so what is it about red feldspar? Well, feldspar, this is actually feldspar in a petri dish reacting to acid. And so as we talked about before, this idea of acid rain, right? More carbon dioxide in the atmosphere and things like that, more pollution leads to more acid rain. And so it actually dissolves the feldspar in the statue. And that's what's really causing the weathering there. So this is a good example of the idea of chemical weathering, same thing that makes these rocks look like this. So I want you to answer in your notes, why did it last for so long in Egypt, but it weathered so quickly in New York City? What is the key difference? And if you can't quite figure it out, take a look at these pictures here. This is a picture of Egypt, and this is a picture of New York City, and what do you notice that's different about them? Well, climate, of course, is the difference, right? So we have a lot more rain in New York City, a lot less rain in Egypt. It's a much drier climate in Egypt. And a lot of that rain that they get in New York City is probably somewhat acidic because there's also quite a bit of pollution in New York City from all the buildings and cars and things like that. So the key thing there is that climate affects the rate of weathering. So climate has a major effect on the weathering. It depends on the type of climate you're in as far as what type of weathering happens and the rate at which that weathering happens. So speaking of that, we need to talk about different rates of weathering. So first of all, the idea of things weathering at different speeds is called differential weathering. This means usually means that softer rock weathers faster than harder rock. You can see this idea right here. This part here is made out of a harder type of rock. This is what we would call an intrusion. And so that was some lava that probably seeped into a crack that was in this darker color rock. And that igneous rock that became there is a harder material than the darker color rock that surrounds it. Remember, this is more of a felsic rock here, right? And this is a mafic rock here. And felsic materials tend to be harder than mafic materials. And so that's why this happens here. So that picture is a very good example of the idea of differential weathering. So differential weathering can be affected by things like the composition of the rock, the surface area. We'll talk a little bit more about that in class, but as a rock gets broken down into more and more pieces, there's more and more surface area. So for example, the surface area is just it's the surface. It's the part that you can see, the part that's touching the air. But if you break the rock down into smaller pieces, this little area right in here, right, you can see that now. It's touching the air, so there's more surface area. And if we break it down into even more pieces, all these little faces here, well, they weren't touching the air before, but they are now. So the more you break something down into smaller pieces, the more surface area it has, and so the more contact it has with the agents of weathering like wind and water and acidic rain and things like that. And last but not least, what is it? Climate. All right, there you have it. We talked about weathering. We talked about the fact that weathering is the physical or chemical breakdown of rocks. We talked about one type of weathering, which is mechanical weathering. This means broken down physically. Again, think of just smashing a rock with a hammer. We have different types, including ice wedging, abrasion, and biological. And then we also have chemical weathering, with our main example being Cleopatra's Needle. We'll talk about some other examples of that. And this is chemical processes, including oxidation or rust, hydrolysis, and acid precipitation. And we have the idea of differential weathering, which is the idea that softer rocks weather faster than harder rocks. And this can be affected by the composition of the rocks, the surface area of the rocks, and the climate in which the rocks are in. And we'll talk a lot more about this in class, and I'll see you then.